Hello students, today we are going to start our second unit and we are going to discuss the topic called as error detection. So before starting our second unit, we are going to do a short catch up on the first unit what we have discussed so far. In unit 1, we have discussed what is meant by a network and what are the different categories and components of networks we are having. After that, we discussed about line configuration and topologies and what are the advantages and disadvantages topologies we have discussed. Then we move on to our OSI ISO model. That means ISO is a standard organization and OSI is a open system interconnection model. So in that we have 7 phases like presentation, data link, session, transport, presentation, application. Likewise, we have 7 layers and we have discussed overall functionalities of each and every module. Then at last we move to the protocols, that means HDLC protocol, IEEE 803 protocol, and we have discussed when and where those protocols are applicable while performing a network collaboration. So these are all the overall topics that we have discussed. So in the second unit, we are going to mainly concentrate on one of the OSI model layer, such as data link layer. So we all know, as we discussed in the earlier chapters, data link layer has few responsibilities like fragmentation, adding addresses to the packets frame, and then checking flow control and error control. So we are going to discuss about the first topic called as error control. So introduction. Network must be able to transfer data from one device to another device with complete accuracy. The data can be corrupted during the transmission. So we all know during the noise occurrence or the length of the transmission medium is little bit longer. Sometimes the signal may get weaker or due to external lights it may lost or completely removed from the data, or sometimes it may be hacked. So how we are going to find those things? For reliable communications, errors must be detected and also corrected. So as we know, the only error detection is not our job. We have to do both error correction and then error detection. So error detection and corrections are implemented either at data link layer or transport layer of the OSI model. So both layer can do the services. So as we discuss, we are going to see the types of errors. The first error is called as single bit error. Next one, multi-bit or burst. More or less multi-bit and burst errors are same. So let us discuss what is single bit error. Single bit errors are the least likely types of errors in a serial data transmission because the noise must be have a very short duration, which is very rare. However, these kind of errors happen in parallel transmission. So what they are trying to say is, by this definition we understood that so the occurrence of a single bit error is not going to happen more often, it is rarely going to happen. It is because why we are going to uh, do the single bit error correction. If the noise occurrence there may error, but if the length of the noise is very less, at the time only there is a possibility of single bit error. But in general speaking, the noise length of the noise will be little bit longer than a single bit error. So single bit error are going to occur in a very few occasions only. Next one, the examples that we are going to discuss here. If a data is sent at 1 Mbps, then each bit at least 1 by 1000 seconds or 1 microseconds. For a single bit error to occur, the noise must have a duration of only 1 microseconds, which is very rare. So they are telling that if there is a chance of a single bit error, the noise must be very less. That means if it is 1 microsecond, then we can tell it is a single bit error, which is rarely to occur. But anyhow, we are going to see the in center has sent the value as 4 zeros 0010. So the fifth zero is replaced by 1 because of the error. So this is called as single bit. We all know 8 bits makes 1 byte. So during that 8 bits, if any one singular bit changed from its original value to a new value, then we are going to call it as a single bit error. What is doing burst error or multiple errors? So burst errors or multiple errors are most likely to happen in a series transmission since the duration of noise is normally longer than the duration of a bit. So as we discussed, the noise is longer than 1 microsecond, then there is a chances called burst errors. That means multiple bits of the numbers can be changed. The number of bits affected depends upon the data rate at which the duration of the noise. So two things decides the errors. The one is data bits rate, at which rate I am going to transfer the data from a source to destination. Second one is the duration, how much time it takes to transfer the data, and then the noise occurred during the transmission media. So these things decides the fact our errors. Example, data is sent at a rate of 1 kbps, then the noise of 1 by 100 seconds can affect 10 bits. So assume that. And if the data rate is 1 mbps, then the noise of 1 per second can be 10,000 bits. So these are all the possible bits of error. So in this example, we can see from the center side to the receiver side, 2 bits has been corrupted. The second 0, 1 has been replaced by the 0, and the fifth 0 is replaced by 1. So these are 2 bits error or multi-bit errors. Likewise, the second example, we have seen 0 0 has been replaced by 1 1, 1 has been 0 replaced by 0, and 0 0 has been replaced by double 1. So in this second example, we have 5 bits has been corrupted during the noise. So far we have discussed what are the types of error we are having, and now is the time to discuss about how we can detect those errors. Error detection means decide whether the received data is correct or not without having a copy of the original message. So I don't have a copy of the original message, then I have to find out whether the received message is correct or not, and this thing is mostly going to happen at the receiver side. Error detection uses the concept of redundancy, which means adding extra bits to the detecting errors at the destination. That means to my actual data, I am going to add some extra bit of data. It helps me to find out whether the given data is at original data or not. So redundancy in the sense, I am going to add some extra bits called as parity bits. So and by checking these parity bits, I am going to find out whether the original data is received in a correct format or not. So it is generated by generator function, and at the receiver side, this redundancy bits will be checked by the uh, uh, checker function. So at the sender side, the redundancy bits are added by generator function, and the receiver side, the redundancy bits will be checked by the checker function. Four types of redundancy checks used are VRC, vertical redundancy checks, longitudinal redundancy check, that means LRC, CRC, cyclic redundancy check, and the last one is called as checksum. So vertical redundancy check are in its performance. So vertical redundancy check in the sense we are going to generate even parity or odd parity for a single bit. That means if the parity bit in the sense extra bit, if we are following even number of parity bits, then the original data with the extra bit will produce even number of ones, then it is a even parity bit. If the original bit and the extra bits produce odd number of ones, then it is called as odd parity. Next one is longitudinal redundancy check. So far only one bit is checked in the VRC, whereas in longitudinal redundancy check I am going to do arithmetic additions of all the values. I am going to place it in a tabular format, then I am going to do either odd parity or even parity. For example, if I have four data bits here, 1 2 3 4, and those bits can be redundant or formed into a table, and then at the last row I am going to add the either the odd parity or even parity for all the 8 bits, then I am going to attach the redundancy bit, and this bit will be checked by the receiver. So these are all the comparison between VRC and LRC. Then the next one is cyclic redundancy bit. So here what we are going to do is we are going to add some bits based on the divisor value. That means the original data will be divided by the divisor value, and the remainder bits which is going to get by the operation will be added to the original data, and again the sender will divide the original bit by, that means the original bit then the extra bit by the divisor. If he produces 0, that means the remainder is 0, then there is no occurrence of error. So this is how we are going to do. So cyclic redundancy check, given k bit framework, a message, a transformer generates an n bit sequence known as frame sequence check, so that the resulting frame consisting of k plus n bits is exactly divisible by some predefined numbers. So as we discussed, it's going to say that the same thing. The receiver then divides the incoming frames by same number, and if there is no remainder, assume that there was no error. So this is how the binary division is going to take place. So here if you assume the original value will be 100 100, to that 000 is added at the initial stage, then it is divided by the divisor. By for frequent number of divisions we are having the binary value as 001. This remainder will be replaced by the for initial zeros. We are going to replace the initial zeros by 001 and we are going to send it to the receiver, and the receiver will perform the same operation with instead of 000 he is going to perform it 001, and it's going to also divide it by same divisor 1101, and if the remainder is 000 then it is a no error, there is no error detected in this particular transmission. So I hope you people understood each and everything that we have discussed so far, and finally we are going to conclude what we have seen today. So today we have seen what are the error detection and error correction concepts. In error correction we have seen what are the types of errors we have, and we have discussed two types, single bit or multi-bit or burst bit. And in the error detection method we have discussed four methods: LRC, vertical redundancy check; CRC, cyclic redundancy check; uh, yeah, LRC, longitudinal redundancy check; and at last we have discussed the checksum options by using a divisor. So I hope all of you understood the topics. Thank you, students.